Hello, ladies and gentlemen, and thank you for listening to Mr. Laxton's video on these 5.1 Algebra 2 notes. Alright, so to start us off, your essential question for today is how do I graph quadratic functions? Alright, so in chapter 2 we looked at graphing lines and graphing y equals mx plus b, but now in this chapter we're looking at how do I graph quadratic functions. So these just don't have x to the first power anymore, these have x squareds now. So we're looking at kind of this y equals x squared. So a quadratic function has the form, and this is kind of the form that we're going to be looking at all this chapter. F of x is equal to ax squared plus bx plus c. And this is what we call standard form. All right, and we also have here a parabola, and a parabola is a graph of a quadratic function that is U-shaped. So we're looking at graphs that look like U's this chapter. Vertex is the lowest point on a parabola that opens up, or the highest point on a parabola that opens down. So again, kind of like the vertex of those V graphs, it's that lowest point or the highest point. All right, axis of symmetry is the vertical line through the vertex that divides the parabola into two symmetric halves. So we talked about symmetry, and that's things that are the same on the left and the right. So one thing that's symmetric is a heart. It's the same on the left and the right side there. So that is symmetric. So we're going to look at graphing three forms: standard form, vertex form, and intercept. And we're going to start here with this standard form, and this is going to be kind of the hardest form. It kind of takes the most amount of work. So we're going to start with that guy and kind of work our way to the easier ones. All right, so standard form is this guy right here, ax squared plus bx plus c. The parabola opens up if a is greater than 0. It opens down if a is less than 0. So if it's negative, it'll open down. All right, so the parabola also looks at wider and things like that. We're going to find that out when we graph here. The x-coordinate of the vertex, this is what you're always going to have to remember here, is that this x-coordinate of your vertex is always this x equals the opposite of b over 2a. And this is the axis of symmetry. All right. So x equals the opposite of b over 2a. You're going to seek out what your a, b, and your c are, and then you're going to plug them into that equation, and that's going to tell you where your axis of symmetry is. All right, so I have some things here for graphing in standard form that'll help you out. Here's me talking you through it. All right, so let's look. Our A, our B, and our C is what I kind of always like to point out for myself. So my A is 1, my B is -4, my C is 7. All right, so what I have to do first is I have to find my axis of symmetry. So I'm going to write that down, axis of sim. All right, and this is going to be x equals the opposite of my b, which is -4, over 2 times my a value, which is 1. Okay, so if I look at this, my x value is going to be the opposite. That's going to make 2 positive, so that's going to be 4 over 2, which is 2. All right. Great. So I know that my axis of symmetry is at this x equals 2. So I like to draw a dashed line through there. All right, I have that dashed purple line through x equals 2. So now what I have to do is I have to find out where on this vertical line here is my actual vertex. So what I'm going to do is I'm just going to plug in 2 in for every x here. So I'm going to try to find f of 2, which is just 2 squared minus 4 times 2 plus 7. All right, so if I look to evaluate this guy, I get 4 minus 8 plus 7. 4 minus 8 is -4 plus 7 is 3. So here I get 2 comma 3 is my vertex. All right, so I go over 2, up 3 is my vertex. Okay, so what it says here now is we need to find out what this parabola looks like. So what it says here in number 4, it says I'm going to choose 2 x values on either side of the vertex. Okay, so it doesn't matter which side, either the left or the right. As I'm looking here, I see that if I go on the left side, I have 1 and I have 0. So to me, that says, hey, those numbers are going to be easier to plug in than 2 and 3. Those are just going to be smaller numbers. So I'm going to plug in f of 1 first. All right, and now I'm going to find out where that point is. So if I plug in 1, I just got to find out what my y value is. So I get 1 squared minus 4 times 1 plus 7. 1 squared is 2. Minus 4 plus 7, so I get 2 minus 4 is negative 2 plus 7 is 5. So my point there is 1 comma 5. So I go over 1 up 5. All right, just kidding me. Just kidding. That should not be 1. This, Mr. Laxton makes mistakes too. This is going to be a 1 minus 4 is negative 3 plus 7 is 4. So this is 1 comma 4 here. So excuse me. All right, I'm going to erase that little part right there. I'm going to have 1, 4. I knew that didn't look right. All right, so I got 1 comma 4. So I know that the point that's exactly symmetric to that is right here across that. So those are a couple points to start out my guy there. So now I have to find one more point on the left side, and I'm going to plug in 0. That's right here because it's another point. So I have f of 0 is equal to 0 squared minus 4 times 0 plus 7. All right, plug these guys in. I'm going to get this right this time. 0 squared is 0 minus 0 plus 7, and I get 7. So my point here is 0, 7. All right, so I go 0, 7 is 0 up 7, which is going to be right here. And I know that the point that's exactly symmetric to that is over 2 from that and then up 7. So now I can connect this. Let's go with my black, and I got a black line to connect these guys. Make my U. All right, so this is kind of the one that entitles the most work for you here. You got to find that axis of symmetry here. You got to find out where your actual vertex is, and then you find these 2 points that are either to the left and the right, and that'll tell you where those points that are symmetric. All right, so now moving on, we are going to make it in vertex form. And vertex form is kind of nice because just like we talked about in those absolute values, it has this form y equals a. Now it's not absolute value, it's going to be parentheses x minus h squared plus k. And just like before, this h comma k is going to be my vertex. All right, and again, the h is the opposite of what it looks. All right, so don't forget that. So now my vertex kind of already shoots out for this one, and then I just have to use that vertex and then find 2 points that are either to the left or the right and plug them in. So now here I look at this example what we have here. I see that my h is going to be negative 1 and my k is going to be negative 4. So I have negative 1, negative 4 is my vertex. All right, so I go over negative 1, 1, 2, 3, 4. There's my vertex. I know that my axis of symmetry is right through there. So I'm going to draw my dashed line through there. That's my axis of symmetry. Now what I have to do is I have to plug in some numbers either to the left or the right. So again, I see that 0 and 1 are going to be my 2 that are directly to the right there. So that's going to be easiest. So let's find out what f of 0 is. So let's plug it in. I get 2, 0 plus 1 squared minus 4. Going through here, I'm going to have 2 times 1 minus 4. So here I'm going to end up with negative 2. So I know that my point here is 0, negative 2. Let's plot that. I got 0, negative 2, so that I can go 1 to make my symmetric is 1 to the left of that and go negative 2. Now let's plug in 1, so I get f of 1 is equal to 2 times 1 plus 1 squared minus 4. This is going to be 2 times 4, because 1 plus 1 is 2, then squared, minus 4, so this is going to be 8 minus 4 is 4 there. So my point here is 1 comma 4. So I go over 1, up 4. I can go to the left one. Ooh, a series top. Awesome. And then now I can connect those dots to make my U. All right, so vertex form. It's kind of nice. It tells you your vertex kind of there right away, so I can see my vertex right away. Then I just have to find those 2 points to the left and to the right in that area. All right. Awesome. So let's go to my last one, which is intercept form, which is sort of the easiest one, I think. A little bit different than the other ones here. Vertex form is A, x minus p, and x minus q. So it says here that the x-intercepts are p and q. All right, and remember that p and q are your x-intercepts, and they are the opposite of what they look again. Of what they look. All right, so always pick out those opposites x-intercepts. So it says here, to graph these guys, we are going to identify my x-intercepts, and then I'm going to find the axis of symmetry, which is going to be halfway between those points. Okay, so I can see here that my p is going to be -3 for this one, and my q is going to be 1. So my vertex, or my, my x-intercepts here are going to be -3, 0, and 1, 0. So I graph these guys, I get -3, 0, 1, 0 is right there. Okay, so now those are 2 points on that graph. Those are where they actually intersect with the x-intercepts, and we're going to talk about actually how those work kind of in the next lesson here. But for now, you just have to know that they are the x-intercepts. Now we have to find that point that's directly in between them. So I see that -1 is directly in between -3 and +1. Okay, so I know that that's going to be my axis of symmetry. So my axis of sim is going to be x equals -1. Okay, so now all I really have to do here is I just have to find out where my vertex is on that line. So what I have to do is just plug in -1. So I get f of -1 is equal to negative of -1 plus 3 and -1 minus 1. Okay, so I look here, this is going to be the negative of 2 times -2. So I look here, this is going to be -4, but then that's got a negative, so this is going to be turn out +4. So my vertex here is actually going to be -1, +4. So I go to -1, +4, which is right there, and then now all I have to do, just connect these lines, make my U. So if I go, my left side of my U is going to be right there, and my right side is going to be right there. It makes my U. All right, so 3 ways here. We have intercept, vertex, and standard. Good talking about through those. So see what you can do on this homework, and we will talk to you later. Thanks for listening.